right here from the beginning, the box is pulling downwards on the pulley, and the pulley is pulling upwards on the box. That's a Newton's third law relationship, and that's the tension we're talking about. Now, it is this tension that causes this wheel to spin, for sure. And it's definitely the weight of the box that's creating the tension in the cable. So when I look at the box, I see, weight downwards and tension upwards, and they are not equal. There has to be an unbalanced force here. Now, one of the things I told one of the groups is consistency of direction is going to help you here. I put an arrow here. I'm indicating that's positive. And so I'm going to apply that both to the mass and to the pulley. And that's why I'm going to say M2G minus tension equals M2A. This is going to give me the relationship that governs how the mass falls. Now, the pulley doesn't fall. It's experiencing forces, sure, but I'm going to focus only right now on the force that's causing it to spin. And can we agree that the force that's causing it to spin is this tension that's here? So if I'm looking just at that, there's a torque arm that is directed from the pivot point to where that force is applied, and that's the radius of the pulley. So the torque is going to be R times T times the sine of 90 degrees. Now, truthfully, I wouldn't write all of that down if I was just doing the work. I would just write RT. I'm putting the sign in there just to remind us all that it's a torque, and torque has 3 parts, and I should always be reminding us that torque has 3 parts. But this equals I alpha. Now, it's at this point where I'm going to do things a little different than yesterday. We want everything in terms of one type of acceleration. So it makes the most sense to me to put it all in terms of the linear acceleration. So that's where I told you guys you have to ask yourself, if this thing rotates once, does this mass move downwards one perimeter, one circumference? If it does, then you can make this assessment. I can replace alpha with A over R. That's trying specifically to work in the same variable here. That way I can bring these two relationships together. I can see how they behave together. And there's something else I'm going to probably have to do in a minute, and that probably has to do with putting something in here that represents the inertia of the pulley. Now, if they didn't give it to us, I'd have to leave I. But if they gave us something that we can use, then I'm going to use what they gave us. And when I read the question, they gave us something to use. They said it's 1/2 m1 r squared. So, yeah, there's more work to do on the torque part because torque has so many little extra pieces to it. But in this case, all the r's disappear. That's fairly typical. And I'm left with tension equals 1/2 m1 times A. At the same time, I have m2g minus tension equals m2A. Now, choose your favorite way of doing this, but we need tension and we need acceleration. So pick one to solve for. I think it's easier to solve for acceleration first. So that's what I'm going to solve for. I'm going to eliminate tension and solve for acceleration. And I'm going to do so right here. Because I can just add these two equations together and the tension cancels out. So for you guys who are still, struggling with the math, I say the phrase alphabet soup all the time because it really is. This is the math. And I know you guys like the numbers, but this is what the math looks like for physics. So I added the left side together and the t's canceled, and I'm adding the right side together. You could do substitution if you prefer. like 3 of you, you did substitution where you just plug that right in. It's the same thing. But we want to collect the A's. A few of you didn't know that, but we're going to collect the A's together. And when I do that, oops, sorry, put the parentheses in the wrong spot. And now we're at the end, right? We can get A by itself. So I'm kind of out of space, so I'm going to put it over here on the side, which makes this look like a mess, and I'm sorry, but this is what I've got. I want to leave the bottom open because this is net force equals inertia times acceleration. You still should see at the very end something that looks like Newton's second law. And we have that. The only thing that's causing the system to accelerate is the weight that was hung on the side. That's the unbalanced force. There's inertia. And notice both objects that have inertia show up here. But it's not the entire mass of the pulley. It's only half the mass of the pulley. Now, this is the acceleration of the system. Notice it's a constant. Do you notice that? M1, M2, those things aren't changing as it falls. So this object obeys Galileo's rules of motion because it's just accelerating at a constant rate until we run out of string. So I think that's the hard part of this problem. Yes, sir.
Can you just read up the 1/2 M1 for and the expression for the tension?
So I started here. You understand where this came from, right? Okay, so the answer to that question must be no. You understand where this came from, right?
Yes.
Right?
Oh, because the force is tension, I see.
We good?
Yeah.
So we're good to go? And you're understanding where all the R's cancel out?
Yes.
Okay. So now it's good for the tension? Okay. Now, I understand that what somebody said earlier, if we can't get the acceleration right, we can't get the tension right. That's true. On the other hand, if you're worried about points, if you can't get the acceleration right, then the tension is something that's just going to be calculated by multiplying whatever you got in part 1 by what you have to do in part 2. Meaning, hold on just a minute. Yes, ma'am. Just hold on and be consistent and do part 2. I'm telling you, whatever you get for A in part 1, just use it in part 2 to find the tension. Now, if you conceptualize the problem wrong, you may not be able to get the points. But for question 2, we need to find out what the tension is. You have 2 choices there. You have 2 expressions for tension. You have this one, and you have this one. Doesn't matter which one you choose, the answer will be the same. So if you have to plug acceleration back in somewhere, where do you think you should plug it in? This one here or this one here? We'll say A or B. Who says A? Raise your hand. Who says B? Raise your hand. Yeah, use the simple one. Use the simple one. So that's what we'll do. You just take what you had for A, which is a lot, and go down here and say, okay, tension equals 1/2 M1 times A, and then throw all that garbage here. So M2G over 1/2 M1 plus M2. Should you clean this up? Probably. They would probably like it better if you wrote M1 M2G over M1 plus 2M2. I multiplied the top by M1 and the bottom by 2. Will they still give you credit for this? Probably. But they don't have to. Okay, they say the most simplified solution is the one you're supposed to submit. I think we've done all the hard work here. But I'd like to talk about question 3, and I probably won't get a chance to talk about question 4. So let me tell you what you have to do for question 4 real fast. Do you know that V equals AT plus V naught? Remember I said acceleration is a constant. You have an expression for the acceleration. So this equation gives you velocity as a function of time. Do you also know kinetic energy is 1/2 mv squared? So,
Students and teachers, at this time we will release for a yellow club. Only students with yellow club cards, please have those in your hand when you're walking down the hallways. You might be checked multiple times. If you don't have a yellow club card,